Okay, so what I'm going to cover here is the report structure for merit, and also a couple of extra skills that you need on Insight for manipulating graphs to gain merit. And to gain excellence, you have to be able to gain merit. So you'll notice the report structure covers the same 8 steps, okay, as we've talked about for achieved: problem, plan, data, analysis, conclusion. The main difference, and this PowerPoint is on the Weebly, the main difference is you actually, like in time series, you're actually comparing 2 bivariate data graphs. Now within those 2 graphs, you either keep the same independent variable and change the dependent variable. So what you're looking at is which independent variable predicts the dependent variable better. So you're looking for the best predictor of 2 different dependent variables. Okay, so you're actually only going to choose 3 variables in total, keep the independents the same, and change the dependent variables on the x-axis. So that would be your structure for a merit. Alternatively, you could do it the other way around. You could keep the dependent variables the same and change the independent variable, make those 2 different, and see which one is a better variable to predict the dependent variable. Okay, but you either keep the independent variables the same or the dependent variables the same, and then compare them. So pretty much the big difference is all the way through you're doing 2 graphs and comparing them, much like you did in the time series. For describing the 2 variables, you would obviously still say as one increases, so does the other, or as one decreases, the other increases, whatever way around it, if it's depending on if it's a positive or negative trend. And you'll need to do prediction for each, and then discuss, and this is something we didn't do so well in the time series, discuss the reliability of those predictions. Which prediction is more reliable? Okay, so you're comparing. Okay, I'll leave you to read that structure in a little bit more detail on your own. And then excellence is merit plus the graph of the residuals, which I'm talking about next, plus removing outliers, re-plotting, and then comparing with the original equation. Okay, so those that did excellence last time round, you'll know how to remove variables. And then thirdly, for excellence, you need to maybe look at other models that might work, or lastly, you could discuss extrapolation, and I've talked about what extrapolation is already. And obviously with excellence, you need to have some research there, backing up the results that you find within your own analysis. Okay, let's just do a few things on Insight. What I've got here is I've imported the sports data from the data sets. It's the same example that's in your workbook. So if you want a really detailed example, go and look in here for sports data. And it's also the same example as I've already put on the Weebly, that you can see that I've sort of talked about through here. LBM stands for lean body mass. And we have to understand that lean body mass means your weight minus the fat. So it actually becomes bone weight. So if you remove all the fat on your body, you end up with your bone weight. So I'm going to talk about LBM, lean body mass, and compare that with weight in just a minute. So when you're referring to my exemplar for merit, I've used the sports data one, which is in the workbook. Okay, as per usual, you're choosing some variables to make a scatter plot. I've decided that I'm going to use my weight to predict my height. Well, I'm actually going to start with that one. My lean, it's not surprising that there's a correlation between your lean LBM, lean body mass, and your weight, because they effectively are both weighing the person. One of them's weighing everything including fat, one of them's weighing just your bone structure. So it's not surprising that there's some correlation between them. So that's going to be my first one, but then I'm going to, because I've actually had a look already at the scatter plot matrix and I've highlighted everything, and okay, hold down shift, and have a look at all the different combinations of variables. I've looked there closely and thought, oh yes, BMI and where's LBM? I haven't even highlighted LBM. But I've already looked at this and decided which three variables I'm going to use, and you can kind of see the ones that would be good. HC and versus HG, whatever those two variables are, would make a nice linear trend. Which other one? SSF versus X body fat, whatever that means, would make a nice linear trend. So that just gives you an overview of all the different combinations. Nice to do at the beginning of your internal, just to analyze everything really quickly. Anyway, as per usual, choose a graph. Now I'm using weight, my actual body weight, to predict lean body mass, and I think that's the right way around, because it's how do you measure someone's bones without killing them?
Can't you calculate the body fat?
Yeah, so I'm not a sports scientist, so I'm not even sure how they measure someone's lean body mass, but there is some calculation involved. So I think if I wanted to predict someone's lean body mass, I would use their body weight. So that's my independent variable to predict the dependent variable, lean body mass. So that's really important, getting that right. Otherwise, the whole thing sort of doesn't really make sense. Same pattern, you would add to the plot a linear line. Hopefully it would plot. Why is it not working? It should have given me a line. I think I'm just going to quickly import the data again and just see if that makes a difference. Okay, so my line's not coming up for some reason. I think from this point I would need to restart Insight, and that's a good thing to remember in an exam situation. Someone had to do that in the time series exam. So I'd plot that graph, I would dump it onto a Word document. I'd then plot the other graph of LBM versus height, and notice that I've chosen a variable that straight away I can see that there is this one's going to be a weaker correlation. So I'm actually using exam technique here, because I'm not choosing things that are very similar, I'm choosing things that are quite different, so I can make vast comparisons. Then, once I've done those comparisons, I actually need to choose one of those graphs, whether it be, and I want to choose the one that's stronger, so I'm going to choose the LBM versus weight. Sorry, LBM goes there, weight goes there. Okay, that's the one I'm going to continue to work with and continue to analyze. The next thing I want to do is split, use a third variable, a subset, and split it by gender. Okay, so in other words, I've got all the male athletes on your right and all the female athletes on your left. Okay, and if I click Get Summary, hopefully this works. It's not working because I haven't got a straight line on it. Add to plot. Yeah, it's not working. Once you've got straight lines on both of those, you can click Get Summary and it'll give you a new equation for both those graphs, and then you're going to analyze how those equations have changed compared to your original equation. Okay, and you'll notice there is you can even see it without even, can you see there's a big difference in gradient for females compared to males? Females' gradient is much steeper, and that's to do with, how the female body and male body is made up with different amounts of muscle. So this is a really good one for splitting by gender. Another button that I've just discovered, let me show you.